Okay, number 8, we're continuing to graph the hyperbolas. So we need to get it into standard form, which means it needs to be equal to 1. I'm going to add 561 to both sides to get that constant on the right side. And I'm going to put my x's and y's together. Whichever one's positive, I'm going to put first. So I'm going to have 16. You want to put it away? Okay. Thank you. Hold on. Okay. So we've got 16y squared. And then the other y is 64y. And then we've got minus 25x squared plus 150x equals 561. I do have a calculator here if you need it. I'm going to GCF the y values. I'm going to get 16 times y squared plus 4y minus 25 times x squared. Remember, if I'm taking out a negative, I need to flip this sign. Minus 6. Is that correct? Yeah. X equals 561. And to complete each square, I need to add half of b squared. And that's going to be 4. But I'm multiplying by 16, so that's actually a plus 64 overall. And this is going to be half of 6 is 3. 3 squared is 9. It's going to be plus 9, but I'm multiplying by a negative 25. 9 times negative 25 is negative 225. Again, you got a calculator, so don't be afraid to use it. So we got 16. And it's important to write all of this out because if you make one tiny mistake, it's going to ruin everything. So please write it all out for your own sake. Y squared plus 4y plus 4 minus 25 times x squared minus 6x plus 9 equals, I am going to use that calculator here for this, 561. 561 plus 64 minus 225. Hi, Keo. 400. Should be something that is both divisible by whatever your coefficients are. So 400. When I look here, yeah, 16 and 25. Those are both factors of 400. If it doesn't add up to something nice and even, it's probably not right in my experience. Okay, so now I need to get it equal to 1. Divide by 400 on both sides. I'm going to end up with my standard form of this. I'm pretty sure 16 times 25 is 400, but let's just double check. 16 times 25. Yep, it is. It's often the case that these factors up front are the product of those factors equals your term or constant on the other side. So this is going to be, I'm going to rewrite this as a perfect square. It's the same thing as y plus 2 squared. And 16 over 400 is 25. Minus, this is a perfect square, it's going to be x minus 3 squared over 16. Basically, you're just flipping the numbers there. And of course, we're equal to 1. Now, I know it's in standard form. I also know that I'm subtracting my x squared, so it's got to be a vertical transverse axis. And my center is going to be at, always do the x value first, 3 and negative 2. So I'm going to 3, negative 2 is my center. Okay, and I need to do the vertical part first because it is y squared minus x squared, so that's the square root of 25 or 5. So I'm going to go up 5 there. And then my asymptote is going to be over 4. 1, 2, 3, 4 there. Right. 3, negative 2, up 5 over 4. 3, negative 2, 2, up 5, over 4. Is that right? 3, 2, oh, it's not right. 1, 2, 3, 4. There we go. 3, 2, 7 is 4. Here we go. Moving on to number 9. Number 9 is a pretty difficult problem. The steps themselves aren't so difficult. It's just trying to make sure you don't make any mistakes that ends up being the hard part. In a little bit. You just had change. You don't need it right now. Okay, so I see that the x squared is being minus, so I'm going to start with the y squared, which is 4y squared minus 8y. You just had milk, buddy. Minus x squared plus 6x. I'm going to add the 9 to both sides, plus 9. We're getting it into standard form first. We can find the center, and then we'll talk about the foci after that. Okay, so I'm going to GCF of 4. I've got y squared minus 2y. And I'm going to GCF of 1, which just means I'm going to have x squared plus 6x. Oops, that's incorrect. Because if I factor out that negative 1, yes, this is going to be positive, this is going to be negative. See what I mean by little mistakes possible? I've done that many, many a time. It's very important to check your individual steps. Okay, so to complete this square, I'm going to take half of b squared, and that is 1. So I'm going to be adding 1 times 4, which is 4, so plus 4. Okay, half of negative 6 is negative 3, squared is 9. It'll be plus 9, but it's being multiplied by a negative, so it's going to be minus 9. So 9 plus 4 minus 9 is just 4. That looks good because I see 4 and negative 1 are both, when I divide by 4, it's going to be nice and even. So let's rewrite everything. This is all being divided by 4 so that this becomes a 1. Well, let me do it one step at a time, actually. So this is 4 times y squared minus 2y plus 1 minus x squared minus 6x plus 9 equals 4. And then I'm going to divide everything by 4. And I get, rewrite this as a perfect square, y minus 1 squared over 4 divided by 4 is 1, minus x, this is a perfect square, x minus 3 squared, and then 1 divided by 4 is 1 over 4, equals 1. There's our standard form, and we have the vertex 3, 1, or excuse me, the center, 3, 1. That's my center. And now I need to figure out which way it's going, which if it's a y squared minus x squared, that means it's going to have a vertical transverse axis. So my foci are always going to land on whatever the axis is. If it's a vertical axis, it's going to be on the y, it's going to be going vertically. And if it's horizontal, then the foci are going to be on that horizontal plane. Let me show you what Alex has to say in their notes, because it is a good set of formulas. You have your standard formulas as usual, where it's going to be x minus y squared or y squared minus x squared. Always a squared and b squared, no matter the side on hyperbolas. Okay, now in this we have the typical c squared equals a squared plus b squared, or a squared equals a squared plus b squared equals c squared, the Pythagorean theorem. Remember, for ellipses, it's a squared minus b squared. So from the center, I'm going to have to travel the distance of c. Okay, how do I find that? Well, I know my a squared and b squared because I have it in standard form. So my a squared is 1 and my b squared is 4. And my c squared is going to be a squared minus the b squared. I'm sensing mistake, or plus the b squared, excuse me. A squared plus the b squared, which I have a very similar setup here. 4 squared is 16, 1 squared is 1. So my c squared is going to equal 1 plus 16. Let me rewrite that from the start here. C squared equals a squared plus b squared. C squared equals 1 squared plus 4 squared. C squared equals 1 plus 16. C squared equals 17. C equals the square root of 17. Okay, so that's the number I need to add and subtract to get the foci. And the foci are going to land on the major axis, and my major axis is going to be vertical. So if it's vertical, up and down, I need to add and subtract that to the y value. If it's horizontal, I need to add and subtract it to the x value. So I'm going to add and subtract the square root of 17 to 1. Notice that they did that to the x value because theirs was a horizontal. They added and subtracted the square root of 5. So here, I'm going to get my 3. That doesn't change because, again, it's a vertical transverse axis. And I'm going to do 1 minus the square root of 17 and 1 plus the square root of 17. Oh, no, made a mistake. Totally normal, but we got to go back and check to see what it is. And this is what I mean by checking your work. It's very frustrating when you make a tiny mistake and you got to go back and find it, see what I did wrong. For your sake, I'm going to pause it while I find it. All right, didn't take me too long to see that these were already squared. This is a squared, this is b squared. So I didn't need to square it again. I don't know why I did, but we all make a simple mistake. So it is the square root of 5 that I need to change it to. So I'm going to go back here and change it to the square root of 5. I kind of saw that earlier when I was like, oh, this is the very similar example, but I didn't catch it. So here we go. There's the correct answer. Like I said, it's very easy to make mistakes on this problem. That's pure proof that there's always these little tiny things that you just accidentally do. So you got to be real careful. You got to go back and check your work, especially on a test. How do you get better at that? Practice. Practice makes permanent, so practice well. Moving on to number 10. On number 10, we have the foci and the vertices of a hyperbola, and we need to find the equation, which it's either going to be x minus h squared over some number minus y minus k squared over some number equals 1, or vice versa, depending on where the axes are. So we need to figure that out. Where are the axes? Well, I've got foci at 1, 4. So here's 1, 2, 3, 4. Foci are going the direction of where the hyperbola is open, and 9, 4. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 4. And the vertices are at 2, 4. So right here, that means it's going to be opening like that, and 8, 4 will be opening like that. And I need to find the equation, so I need to find the center. The center is pretty easy to find. It's just going to be the middle distance between my two vertices. So between 2 and 8, what's exactly in the middle of that? You could do it the long way. 8 plus 2 divided by 2. It's 10 divided by 2 is 5, and then add 5 to 2 or subtract 5 from 8. But I can kind of see, excuse me, 8 plus 2 divided by 2 is 5, so we're going to be at 5. But that doesn't even make sense. 8 plus 2 is 10, right? Divided by 2 is 5. The middle between 8 and 2, it's a distance of 6. Yeah, it is 5. I don't know why I was second guessing that. It is 5. 5, 4. So yeah, if you add them up and divide by 2, you'll find the midpoint of those vertices. It's the midpoint of the vertices. So 5, 4 is my center, and it is horizontal, so it's going to be this formula, x minus h squared over a squared minus y minus k squared over b squared equals 1. Hyperbola and ellipses are always equal to 1. So for the center part, I just got to plug in these numbers. So it's going to be x minus 5 squared over a squared minus y minus 4 squared over b squared equals 1. How do I find my a squared and my b squared? Well, I need to go back to the idea that c squared equals a squared plus b squared for hyperbolas. And I know that my c squared, this I'm going to show you with Alex. C squared is the distance from the center to the foci. The c squared is the distance between the center and the foci. So they found the midpoint there. The c squared is, or c is the distance between the center and either focus. C, the center, distance between the center and the focus. And the, where's the second part? And the a is the distance between the center and the vertex. There we go. So I thought they did it in the other order. A is the distance between the center and the vertex. So the center and the vertex. The c is the distance between the center and the foci. So what does it show on my problem here? Here's my center right there. The distance between the center and the vertex, that's my a. So a is going to be the distance 5, 4 to 2, 4, which is a distance of 3. So 3 squared plus b squared. C is the distance from my center to my foci. So that would be 5, 4 to 1, 4, which is a distance of 4 squared. So I've got 16 equals 9 plus b squared. I'm going to subtract 9 from both sides, minus 9, and 16 minus 9 is 7, right? 7 plus 9 is 16, yes, equals b squared. The square root of 7 equals b. We don't really need the square root of it, though, in this one, because we just need b squared. B squared is 7, so this is going to be 7. And a squared, we already figured that out, is 3 squared, or 9. So we have our answer right there, x minus 5 squared over 9 minus y minus 4 squared over 7 equals 1. 5, 4, 9, 7. Let's check it. Parentheses, x minus 5 squared over 9 minus y minus 4 squared over 7. Don't forget the equals 1. Get it? Check. There we go. Tough problems, make sure to check your work. Number 11. All right, number 11, we need to figure out what type of conic these are by the equations. Talked about it earlier when I was doing the ellipses. We've got circles, parabolas, ellipses, and hyperbolas, and they all have their different formulas. You want to see what those formulas are? Alex has a great example, but you do want to commit them to memory. Here's a circle, x squared minus h squared, x minus h squared plus y minus k squared equals r squared. Here's an ellipse. Notice that they're both being added. Right. Here's a hyperbola. Notice that they're being subtracted. And they're ellipses and hyperbolas, they're equal to 1. And then we've got our parabolas where only one of the values is being squared, either y or x. Those ones are kind of easy to figure out. A line will have no squares at all. So this is a parabola. Know that much, but let's write that out here and get it into the form we want. We need to get equal to x, so I'm going to add x over here and subtract 7. So I've got 4y squared minus 8y equals x minus 7. Factor out the 4, and I get y squared minus 2y, x minus 7. And then I need to complete this square by adding 1, which is being multiplied by 4, so it's basically adding 4. And then I get 4 times y squared minus 2y plus 1 equals x minus 3 now. And then I'm going to have to divide. I don't even know if this is necessary. Oopsies. Divide. Okay, now, what is going on? Getting some funny stuff going on here. Let me write, please. Let me write, please. The vertex, and there's multiple ways to do this. There we go. 4 times y squared minus, let me complete the square here. This is going to be 4 times y minus 1 squared equals x minus 3. And I'm going to divide by 4 on both sides. And I get y minus 1 squared equals 1 over 4 times x minus 3. So I'm going to have my center at 3, 1. Or vertex at 3, 1. 3, 1. 3, always x with x, y with y. 3, 1. I'm not going to show the other way for the sake of time. Let's take a look at the second one here. I need to get my x values together and my y values. I noticed that x is negative, so I'm going to do the y's first. 16y squared minus 32y minus 4x squared minus 24x equals 84. I added the 84 to both sides to get the constant on the other side. Now I'm going to factor 16 out from the y squared minus 2y minus 4 times x squared plus 6x equals 84. Going to add 1 to complete that square times 16 is plus 16. I'm going to add 9 to complete that square times negative 4 is negative 36. So I've got 84 plus 16 minus 36. If I add 16, that would be 100. I believe 6 is 9. Yeah, 100 minus 36 is going to be 64. Let's double check. Don't want to be wrong. Gotta borrow. 10 minus 6 is 4. 9 minus 3 is 6. That is correct. Okie dokie. So that is going to be equal to, what did I say, 64? I've got 16 times y minus 1 squared minus 4 times x plus 3 squared. And I would have to divide by 64 on both sides to get it to equal to 1. It doesn't look like it's going to be a circle because I have these factors in front there. If they were both exactly the same factors and I could divide by that factor and set it equal to something squared, that would be a circle. But because they're not going to end up being the same, it's not going to be a circle. It's going to be a, this should be a hyperbola because I'm subtracting one of them. So I'm going to have y minus 1 squared over 4 minus x plus 3 squared over 16 equals 1. That is a hyperbola, and it's going to have a center at negative 3, 1. Negative 3, 1. All right. There we go. Moving on to number 12. Okay, on this one it slows down a little bit. It's a system of equations. And we're only doing parabolas and lines, so it's not too bad. We don't have any hyperbolas, ellipses, or centers here. It's just a system. You could potentially have a system with any type of function. So if they're both equal to y here in this system, then they're both equal to each other, which means negative 2x squared is equal to negative 2x minus 4. And I can solve that algebraically. But for this one, they're asking me to graph it. I need to graph this one, and I need to graph that one, and then find the solution. So I'm going to have to do that on ALEC. Well, I could show you here on this. Negative 2x squared here. This is a parabola. X is being squared, so it's a vertical parabola, and it's going down because it's negative. So it's going to be 0, 0 for the vertex here. There's no trinomial or anything. I don't have to do negative b over 2a to find the center or anything like that. I'm just going to go over 1 and down 2 those points, and that'll give me my parabola. Hopefully you remember how to do a line. It's pretty easy. Here's my y-intercept, negative 4, and then I've got a slope of negative 2, down 2 over 1, and it's going to be going through those 2 points there, which are much easier to see on ALEX. But I'm going to have 2 solutions. So let's do the parabola first. Put it here at 0, 0. I'm going to go down. It's going to go over 1, down 2. And then the line, it starts at negative 4 and goes down 2 over 1. So I've got one solution at negative 1, negative 2. And I've got another solution, click this OR button, at 2, negative 8. Okay, let's move on to number 13. Number 13, we do need to solve it algebraically. So if they're both equal to y, set them equal to each other. Negative 4x plus 19. I'm just going to get it all equal to 0. So 4x is going to be added to both sides, and 19 is going to be subtracted from both sides. I've got 3x squared, oopsies, minus 3x minus 18 equals 0. I see a GCF. Always check for GCFs. 3 is what I can factor both, all 3 terms by, excuse me. So I get x squared minus x minus 6 equals 0. And then I just divide both sides by 3, and it disappears. Boom. X squared minus 6 minus x minus 6 equals 0. Can I factor this? I think I can. I believe it is, oops. Oh, here's that situation again. I gotta do that. Bring it back up. And I've got x minus 3, x plus 2 equals 0. So that means x equals 3 and negative 2. That only gives me my x values though. So I'm going to plug those in. Here's 3, and one of them is going to be negative 2. And then I got to solve for y. Let's plug it into the linear one because that's easier. Negative 4 times 3 is negative 12. Negative 12 plus 19 is 7. Okay, plug in negative 2. Negative 2 times negative 4 is 8. 18 plus 19 is 37. 37, negative 2, 37. Uh-oh, made a mistake somewhere here. Let's pause it. I think I just added wrong here. I think this is a 27. I'm trying to rush. There we go.